Hey everyone and welcome back. Imagine your Java program calculates a student's age. The program knows the answer is 27. But how does the program remember that 27 is the student's age? If the student's age changes later, how do we update it? What happens if you try to use a variable before giving it a value? And why does Java sometimes show errors like variable might not have been initialized or cannot find symbol? The answer to these questions lies in one of the most fundamental concepts in Java: variables. In today's lesson, we won't just learn what a variable is. We will understand how to declare variables, assign and update their values, how variable scope works, why compiler error occur, and how to avoid the common mistakes almost every beginner makes. As always, don't just watch the video, open IntelliJ IDEA, create a project, code along with me, and experiment with every example. Because programming is learned by writing code, not by watching. Let's create a new Java class named variable demo and add the main method. Everything we write in the first part of today's lesson will be inside this main method. Now let's understand what a variable actually is. A variable is a named storage location in memory used to hold data while a program is running. It has a specific type, a unique name, and a value. Here is a simple example. Int age is equal to 27. Let's break this statement down. Int is the data type. It tells Java what kind of value the variable can hold. Age is the variable name, also called an identifier. Equal to is the assignment operator. 27 is the initial value, and semicolon marks the end of the statement. Now let's see how we create variables step by step. Declaration means telling Java that a variable with a specific name and data type exists. The basic syntax is data type variable name. For example, int age, double salary, char grade, and string name. We have now declared 5 local variables inside our main method. We have told Java that age is an int, salary is a double, grade is a char, past is a boolean, and name is a string. However, we haven't given these variables any values yet. So, what happens if we try to print age right now? IntelliJ IDEA immediately flags a compilation error. Variable age might not have been initialized. Why? Because Java requires a local variable to be definitely assigned a value before we can read or print it. So this code won't compile. Now let's give our variables their initial values. Age is equal to 27, salary is equal to 77,000.75, grade is equal to B, past is equal to true, and name is equal to techie. When we declare a variable and provide its value in the same line, we are initializing it. Now that every variable has a value, we can safely print them. Running these lines outputs their respective values cleanly. To make our output user-friendly, let's add labels using the plus operator. Let's run the program. What's happening here? When the plus operator is used with a string, Java performs string concatenation. It joins the text label and the variable value into a single line of text. We can even build complete sentences. For example, output is Techie is 27 years old. Remember, the plus operator can also perform arithmetic addition when used between numbers. For example, int result is equal to 10 plus 20. Here, plus performs addition, giving an output of 30. We will explore operators in much more detail in a future video. Declaration, initialization, and assignment terms are often confusing for beginners, so let's make the difference clear. Declaration introduces the variable by specifying its type and name. Example, int marks. We are telling Java there is an integer variable called marks, but we haven't assigned a value yet. When we provide an initial value as part of the declaration, we are initializing the variable. Example, int marks is equal to 90. This statement contains both declaration and the initial value. Think of it like this: create the variable, give it its first value. Assignment means assigning a value to a variable after the variable has been declared. It can also be used to change the variable's current value. Example, marks is equal to 95. Now, here is how updating a variable or reassignment works. You can assign a new value to an existing variable at any point. Example, marks is equal to 98. When you assign a new value like 98, Java simply overwrites the old value 95 in memory. A variable holds only one value at a time. Important beginner rule is once a variable has been declared, never write its data type again when assigning a new value. Example, marks is equal to 99 is correct, but int marks is equal to 100 gives error. Java thinks you are trying to declare a duplicate variable named marks in the same scope, so you will get a compilation error. Now, let's make this assignment pattern slightly more interesting with arithmetic. Int number is equal to 5. S out number. Number is equal to 15. Print number. Number is equal to number plus 10. Out number. Let's trace this line. Number is equal to number plus 10. Java evaluates the right hand side first. Current value of the number is 15. So 15 plus 10 is equal to 25. Then it assigns that result 25 back into number, overwriting 15. If we run this, okay, let me comment out this. If we run this program, we can see the final output number is 25. This pattern, read the current value, calculate something, and store the result back, is used everywhere in programming. Java allows us to declare multiple variables of the same type in a single line. Example, int a is equal to 10, b is equal to 20, c is equal to 30. Or we can declare them together and assign values later. Int abc then assigns values: a is equal to 10, b is equal to 20, c is equal to 30. However, we cannot mix different data types in one statement. Example, int age is equal to 27, double salary is equal to 77,000.75. This will give us compilation error. While multiple declarations are valid syntax, writing one variable per line is standard industry practice. It makes your code much cleaner, easier to read, and easier to debug. Let's test your understanding. Look at this snippet without running it in IDE. What will be printed? Let's trace it together. Marks start at 50. Marks are updated to 75. Marks is equal to marks plus 10, that is 75 plus 10, which equals 85. So, the output is 85. If you predicted 85, fantastic work. If not, don't worry. Tracing values line by line is a skill that comes with practice. All the variables we have created so far inside the main method are called local variables. Local variables are declared inside a method, constructor, or block. One very important rule is Java requires a local variable to be explicitly assigned a value before you can read or print it. Consider this. In temperature, let's print it. This causes a compilation error because the compiler cannot prove that temperature has been assigned a value before we try to use it. However, assigning a value first works cleanly. Temperature is equal to 28. There is no compiler error. The compiler can clearly see that temperature receives a value before we read it. This rule helps Java catch many programming mistakes at compile time. Instead of silently allowing us to use an unknown value, Java requires us to explicitly assign a value before reading a local variable. This is one of the reasons you will often see the error variable might not have been initialized. Now let's talk about another important concept, scope. Scope defines where a variable can be accessed in your code. For local variables, scope is strictly limited to the block where the variable is declared. To see this in action, I have created a new class called variable scope and added this code to the main method. Why does line 14 fail? Variable b was declared inside the if block. Once the execution leaves the closing brace, variable b goes out of scope and disappears. Variable a, however, was declared outside the if block, so it remains accessible throughout the main method. Rule to remember is a local variable can only be accessed within the block where it was created. Let's test your scope knowledge. Take a look at this code. Which line causes an error? Pause the video and think. I am showing this challenge on a slide rather than in IntelliJ because IntelliJ immediately highlights the error in red, which would spoil the answer. Let's check the answer. The final line system.out.println bonus fails to compile with a cannot find symbol error because bonus does not exist outside the if block. Whenever you see cannot find symbol in IntelliJ, always check if you are attempting to access a variable outside its scope. So far, every variable we have created has lived inside the main method. These are called local variables. They are temporary and only exist while that method is running. However, Java also allows us to declare variables directly inside a class outside of any method. Depending on how they are declared, these become instance variables or static variables. Let's take a quick preview. Here, the key difference between these three categories is local variables like marks are declared inside a method or block. They can only be accessed within that method and they require explicit assignment before reading. Instance variables like age are declared inside a class but outside any method. Every single object created from this class gets its own copy of this variable. Static variables like college code are declared inside a class with the static keyword. This variable belongs to the class itself, so a single copy is shared across the entire program. If instance and static variables feel a bit abstract right now, don't worry, we are only getting a quick preview here. We have a dedicated lesson coming up where we will explore classes, objects, and object memory in detail. Now it's time to test your skills in IntelliJ. Pause the video and create a new class called Student Profile in IntelliJ. Your task is to create a student profile using variables like name, age, college, city, percentage, grade, and past. Choose appropriate data types, for example, string, int, double, char, or boolean. Then print them in a neat format using string concatenation with plus operator. Your output should look something like this. Ready for the next one? Now imagine the student's percentage improves. Originally 77.5. Now change it to 90.0. Then update the grade if necessary and print the updated values. The important rule is don't redeclare the variables. Use assignment operator. Example percentage is equal to 90.0 or grade is equal to A. Now let's finish with a debugging challenge. Look at these pieces of code. Int age system.out.println int age is equal to 25, int marks is equal to 95.5. There are three separate issues. Pause the video and try to identify them before I explain the answers. The first problem is int age system.out.println age. Age was declared, but it hasn't been assigned a value before we try to read it. So this will give an error. The second problem is int age is equal to 25. Age was already declared in the same scope. So we are trying to redeclare another variable with the same name. And the third problem is int marks is equal to 95.5. 95.5 is a double literal, so it cannot be assigned directly to an int variable without a loss of precision error. We will learn much more about numeric literals and type conversion in future lessons. Let's quickly recap everything we learned. A variable is a named memory location that stores a value. Declaration introduces the variable name and type. Initialization gives an initial value, whereas assignment updates an existing variable. Local variables must be initialized before reading them. Scope dictates where a variable can be accessed. And whenever you are working with local variables, always ask yourself two questions. Has this local variable been assigned a value, or am I attempting to access it within its scope? These two questions will help you understand many beginner Java errors. In our next video, we will explore literals and constants in Java. We will answer why 25 is an int by default, why 5.5 is a double, why float requires an f suffix, and how the final keyword creates constants. Make sure to post your solutions to the coding challenges in the comments below. Hit the like button, subscribe, and I will see you in the next lesson. Thank you for watching. Keep learning, keep growing, and stay connected for more updates.